Welcome to lesson 4 of our Learning Together series. In this lesson, we're going to go over null hypothesis statistical testing and how would you conduct a t-test and use a linear model to show the same thing. A null hypothesis assumes that any difference is due to random chance. So in our case, we're saying that the difference in body mass of male and female penguins is due to random chance. The alternative hypothesis is saying that the difference is not due to random chance, it's due to the predictor variable, in this case sex. The p-value is how likely is our data, or data more extreme than ours, due to random chance. In other words, assuming that the null hypothesis is true, how likely is our data? And if our p-value is less than 0.05 or less than 5%, it means our results is statistically significant. A t-test compares the mean of two categories, and a t-test is a type of linear regression in which the predictor variable or the explanatory variable is categorical, in which there are only two categories. So the first thing we're going to do is create a histogram and check for normality. So using the function hist, H-I-S-T, parentheses penguins, $ body mass, what we're saying is that in the penguins data frame, for the variable body mass, we want to see the distribution. And it's relatively normally distributed. Okay, so now let's look at the qqnorm. So it's fairly normally distributed. What it does is it compares the theoretical quantiles compared to the quantiles of our sample. And what we see is it's almost a straight line. The straighter the line is, the less curvature there is, the more normally distributed it is. Alright, so now let's check the mean for body mass of females and males, and then the difference between the mean for body mass of males and females. Okay, so we're creating a new object called females_mean, and we're using the mean function to find the mean of body mass for our subset females that we created in lesson 2. And it's right here, 3,862.3. And now let's do the same for males, and the average is 4,545.6. And let's find the difference of the body mass of males minus the body mass of females, and it's 683.4. So let's actually assign that to an object. So let's call that difference mean, and let's run that again because I want that as an object. And now we see it right here. Okay, so now let's run a t-test and a linear model. So using the t-test function, it's t.test, parentheses, males $ body mass, comma, females $ body mass, and we're saying that it's true that the variance is equal. What we're saying is that in our subset males, we're looking at the variable body mass, and we're going to compare that to the body mass of our subset females, and we're assuming that there is equal variance. And what we see here is the p-value is really, really small, so that means our results are statistically significant. It gives us a 95% confidence interval, and it tells us the mean. And our mean, since we put males first, it's males comma females, that's the mean for the males, and then this is the mean for the females. So now let's run the linear model, and I want to see the summary of the linear model. So I'm doing the summary function and then the linear model function. And when you use the linear model, it's y squiggle x, and we're doing that in the penguins data set. So what that means is that we want to see how a response variable, so in this case body mass, is affected by a predictor variable, in this case sex. And I already ran it, so let's look at it. So if we look at the p-value, it's 4.897 times 10 to the negative 16th, and that's the same as when we did the t-test. So that's how a t-test is a type of linear model. The p-values are the same because it does the same thing. So the way it shows the mean is a little bit different. So female is first in the alphabet compared to male. F is before M. So it's going to tell us the mean for female, which is 3,862. It tells us the mean for male by adding that number to the intercept. So it's adding the 683.41 to 3,862.27, and that will give us the mean for male. Alright, so let's do a quick recap for today's lesson. We checked to see if our data was normally distributed using the hist function and the qqnorm function. We then wanted to see the mean for body mass for females and for males, and then the difference in body mass between the two sexes. We then conducted a t-test in two different ways. We used the t.test function, and then we used the LM, or linear model function. And what we saw was those two functions gave us the same p-value, and that shows that a t-test is a special type of linear model, in which the explanatory variable is categorical, while the response variable is still continuous. Alright, I hope you learned something new, and happy coding!